We're looking now at annual motion, so how things in the sky change due to Earth's motion in its orbit around the sun. So it's termed a revolution. And part of this that we're going to explore is how the sky changes from month to month, where there are certain groups of stars that are going to be associated with springtime or wintertime or so forth. All right, and a little bit of terminology. If Earth is spinning for its daily motion, so the axis of rotation is inside the Earth itself, that's called a rotation. And then for the movement of the Earth around the sun, that is called a revolution because the axis of rotation is outside of the body. And looking down on the solar system, both the rotation of the Earth and the revolution of the Earth are counterclockwise as viewed from above. Okay, so let's talk about these two figures. So figure 1 shows a sun-centered or heliocentric perspective view of the Earth-Sun system, indicating the direction of both the daily rotation of Earth about its own axis and its annual orbit about the sun. You are the observer shown in figure 1. So you're standing right there. You're located on Earth in the northern hemisphere and you are facing south. And figure 2 shows a horizon view of what you would see when facing south on this night at the same time as shown in figure 1. So this is a way of representing half of the sky that you can see at this point in time. So this is the half of the sky you would see if you're facing south. If you would turn around 180 degrees and face north, then you would get to see the other half of the sky. So you have a few questions to go through based on figure 1 and figure 2. Alright, so which labeled constellation do you see highest in the southern sky? Well, Cancer, Gemini, Taurus, Aries, Pisces. Taurus is tallest of allest. For the time shown, which constellation is just to the east, i.e. to your left when you're facing south, and which constellation is just to the west, i.e. to your right when you are facing south, of the highest constellation at this instant? So there's Taurus, so just to the east is going to be Gemini, and just to the west is going to be Aries. Noting that you are exactly on the opposite side of the Earth from the sun, what time is it? So I am this observer. I am halfway between sunset and sunrise, and I am opposite the direction of noon, so that means this is my local midnight. In 6 hours, will the observer be able to see the sun? If not, why not? If so, in what direction? North, south, east, or west would you look to see the sun? Okay. So after 6 hours, Earth will have made another quarter turn. And so that means I would be right here, which means I could see the sun. And the direction that I'm going to look is the east. Which constellation will be behind the sun at the time described in question 4? Well, Scorpius. When it is noon for the observer, so not at sunrise, but another 6 hours later, when it's going to be noon, what constellation will be behind the sun? Well, over a day's time, Earth has hardly moved around this circle. It moves about a degree per day. So the constellation that's behind the sun is still Scorpius. Okay. 1 month later, Earth will have moved 1/12 of the way around the sun. You are again facing south while observing at midnight. Which constellation will now be highest in the southern sky? Okay. So after a month's time, Earth is going to move to 1/12 of the way around the circle, so it's about 30 degrees. And we are at midnight, so what constellation is going to be highest in the sky at midnight is Gemini. Do you have to look east or west of the highest constellation that you see now to see the constellation that was highest 1 month ago at midnight? So let's look. Do you have to look east or west of the highest constellation that you see now to see the constellation that was highest 1 month ago at midnight? So the one that's going to be highest now is Gemini. Which direction do I look to see the constellation that was highest a month ago, which is Taurus? I look to the west. All right. Does the constellation that was highest in the sky at midnight a month ago now rise earlier or later than it rose last month? It is going to be rising earlier. And this is how we get different seasonal stars. As the Earth revolves around the sun, we have different constellations in our nighttime sky, and then the general pattern is that every degree around this circle, I'm making things rise earlier and earlier and earlier. What was rising at some given time on one day, and the next day is going to rise a little bit earlier. Okay, let's go on to the next set of questions. So part 2, daily differences. So figure 3 shows the same Earth-Sun view as before, and the bright star Betelgeuse, which is between Taurus and Gemini. So Betelgeuse is a star in the constellation Orion. And it's right there in the winter hexagon. Orion is amidst Gemini and Taurus. So, question 10. Imagine last night you saw the star Betelgeuse just starting to rise on your eastern horizon at 7:15 p.m. At 7:15 p.m. tonight, will Betelgeuse be above, below, or exactly on your eastern horizon? All right, we have a hypothetical debate between our students here. So 2 students are considering their answers to question 10. Student 1. Earth makes one complete rotation about its axis each day, so Betelgeuse will rise at the same time every night. It will therefore be exactly on the eastern horizon. Student 2. Mais non. No. Because Earth goes around the sun, the constellation Taurus rises earlier each month, and so it must rise a little bit earlier each night too. Betelgeuse must do the same thing. Tonight, it will rise a little before 7:15 and be above the eastern horizon by 7:15. Do you agree or disagree with either or both students? Explain your reasoning. So, student 1 is correct for daily motion, but is forgetting about annular motion. And it's not a big difference from day to day, but this question is sort of pinpointing the difference that annular motion makes on a day-to-day basis. And student 2 is correct. Betelgeuse, if it was exactly starting to rise at 7:15 p.m. on one night, on the next night it will already be above the horizon. It will have already risen. Because it's not just the constellations that you can see in your nighttime sky that's shifting, it's your whole view of the nighttime sky. And so if Betelgeuse is rising at some time on one given night, it's going to rise earlier the next night and even earlier the next night after that.